Hi everyone, this is lesson 414, factoring completely. The last few lessons have been about learning how to factor using the tools available to us. Um, and so we've been practicing with area model, the diamond problem, or some of you call it diamond method or X game. And I've kind of drawn those out for you to kind of see the difference. In some books, you might see it like this. Or another, I think like in our Delta Math, we were seeing it as the X game. In the end, it still has the X, right? So same idea. I think it was the last lesson we talked about just factoring more, practicing a little bit more of that. And so what we're going to look at here is factoring completely. Now, factoring completely helps us avoid having more than one answer. And so we're going to go through an example of what I mean by that. And so here's an expression that we're going to work with, 3n squared plus 9n plus 6. I've already started this for us. And as you could see, I worked it out two different ways. I'm starting to work it out two different ways. And I'll talk about both of these ways. For the most part, at this point, I believe almost everything is the same. And so I would recommend having both of these so we could kind of see the difference. And our goal is hopefully to learn how to not have to worry about having twice as much work. All right, so what I'm going to do is I'm going to focus on one of these. And so on the left side, I've filled in all the key information from the original expression. So 3n squared plus 6, that came from the original, plus 9n. All right, so I'm not going to go over the basics of how to set this up because that's in the previous videos. And so hopefully at this point, I'm assuming you know how to set up your area model and the X as well. So all these numbers came from the original problem. 3n squared times 6. When we multiply these two, it gives us our 18n squared. Okay, so that was kind of given to us. What wasn't given to us was the numbers that we need to multiply to give us 18n, and the numbers we multiply or add together to give us 9n. All right, so I've already filled this in for us. So we have 6n and 3n. 6 times 3 is 18. 6 plus 3 gives us 9. And so I'm going to put those in the area model. All right. And then at that point, we would try to figure out what goes on the outside of our area model. And so I've started this for us. And so if I focus on the columns and I look for the greatest common factor, what number goes into 3n squared and 6n? And that would be 3n. And if I focus on the next column, 3n and 6, 3 would be the greatest common factor. All right, so if I start that, then I would go to the rows, and then I could say, okay, 3n times what will give me 3n squared? So that would be an n. Oops, let me put that an n. And then at this point, I could look at 3n times what would give me 6n, and that would have to be a 2. All right, which should make sense. 2 times 3 gives us 6. All right, so then we could fill this in. This would be 3n plus 3 and n plus 2. And then we would have our factors. Right. All right, so that would be us factoring this problem. Now, an alternative to this, right? If let's say this is how I did it, and you say, well, I don't like to start with the columns. I'd actually like to focus on the rows instead. And so if I say, oh, 3n squared and 3n, then that means they have a 3n in common. And then 6n and 6 have a 6 in common. All right, so that sounds right. And so that must mean that down here should be an n, and this should be a 1, right? Because 1 times 3n is 3n, and 1 times 6 is 6, right? All these numbers make sense. They all work. So then I would have n plus 1 and 3n plus 6. All right, awesome. So I solve these. It's the same problem. It's not a different problem. But you notice our answers, our factored answers, are not the same. So here I have 3n plus 3 times n plus 2, and here I have n plus 1 times 3n plus 6. These do not look the same. But yet we know we factored them perfectly. Right? There is no mistakes here. These are both correct, but we have more than one answer. So what we want to try to do is avoid having more than one possible answer. Right? So if I'm looking for this answer on a test and you give me this other answer, it wouldn't be fair for me to mark it wrong. Right? So to avoid confusion, we want to figure out what would be the one answer that for sure everyone should have. And so this is what we're talking about when we talk about factoring completely. So what we should have done, all right, so the next part is going to kind of explain this of what maybe the steps that should have been done from the beginning. All right. And so what we did in the middle of the process was we looked for greatest common factor of the rows or columns. And that's where there was a difference on the two different types or two different answers. But if we actually look for greatest common factor first before the area model, this will help us eliminate possibly having more than one answer. All right, so most of this is written out for us. We'll fill in the blanks. And so we have 3n squared plus 9n plus 6. This is the original problem from the one we just did. If I'm looking for the greatest common factor, I'm looking for what number goes into all three of these. All right, and I'm looking for the greatest number. So the one number for sure that goes into all these is 1. Right? That by default, 1 is always going to be a factor. But I want something bigger than 1. And so obviously 2 doesn't go into these numbers. 3 goes into 3, 3 goes into 9, 3 goes into 6. Perfect. So 3 is the greatest common factor. And so the first step would be to identify what that number is. So it was a 3. And remove it, factor it out from the original expression. So this is usually where students have questions about, like, where did this come from? Where did this is not the original problem. All right, so think about it. If we were actually multiplying this out, so 3 times n squared gives us 3n squared. 3 times 3n gives us 9n. And 3 times 2 gives us 6. All right, so these are the numbers, the terms that we would multiply to 3 to give us the original. All right, some people like to think of this as actually doing division. So if I take 3 and I divide it by 3, it gives me 1. And if I take 9 and I divide it by 3, it gives me 3. All right, so that's 3. And then 6 divided by 3 gives us the 2. All right, so now we have an easier expression to factor. So you'll notice I have the area model and the X game set up for us, but when I put in the numbers, I'm actually using this new expression, right? So it's easier because these numbers are smaller. So I put in an n squared, I put in the plus 2, the 3n goes at the bottom, and so 2n times n squared is 2n squared. So now I'm trying to think of what two numbers can I multiply to give me 2n, but when they add them, they give me a 3n. All right, so and this would be, let's put 2n, a positive 2n, and a positive 1n would work. And so I'm going to put those in. So this would be 2n and positive 2n, positive 1n. And then we could fill in the outside. All right, so then this would be, this is easier because it's just an n squared, so there's no numbers to worry about here. So we have an n and an n, and then we have a plus 1, and we have a plus 2. All right, and that's it. So you'll notice smaller numbers, so I'm going to put n plus 1 and n plus 2. You should also notice I've kept the greatest common factor is still part of the final answer. So when you do have your answer in the final factored form, right, final factored form, you should also include whatever it was that you took out, and then the other factors that we got from our area model, right? So there's a total of 3 factors, 1, 2, 3. All right, and that's pretty much it. This is really how we should be doing the problems, and moving forward, I would expect you to think about, is there a greatest common factor so that we don't end up with more than one answer. All right, so one thing to note is that not all expressions have a greatest common factor greater than 1, but we should always check. All right, so it is possible that there is no number to be taken out. Maybe it's just going to be a 1, and that's it. All right. And so here are a few for you to practice. I've started these for you, but I will let you finish these. And I've kind of made a note here. When we are factoring completely, first thing is check for greatest common factor. Second thing is factor the rest. And then step 3 is write all the factors. So I've kind of set it all up for you, and I've actually taken a look at these and found the greatest common factor. So 5, 15, and 20 all have a 5 in common, right? And then this would be remaining. So 5 times x squared is 5x squared. 5 times 3x is 15x. 5 times negative 4 is negative 20. All right, so kind of follow that process throughout this. And you'll notice I've also kept the greatest common factor in the final answer as well. So it's all set up for you. You just have to fill in the missing parts and then figure out the area model, the terms on the outside, so you could figure out. Right. And so the only difference on these is, I think on part B, you'll notice it has an x cubed, but they all have x's, so that was part of the greatest common factor. So you'll notice I took out an x, which ended up leaving us something that was normal, right? X squared, or something in standard form like we expect. The last one, you'll notice this is one of those that have a term missing, but we were still able to take out a common factor, 2, and then x squared minus 25 has a missing term, which I included here as well. All right, so you still have 3 terms, and I included that in the models as well, the tools. All right, so I'm going to let you try those, and we could go over the answers to these after you watch the video. Hopefully you've written these out. and then I'll go over the answers in class. All right, that's it, and good luck with these.